Okay, so let's solve this. Problem number 3. So we have a slope surface which is at an angle 45 degree. There is an object A, and on top of it we have another object B, and there is a pulley provided here and it is connected using a cable. So this is B, this is A, and let this be mu A, the coefficient of friction between the slope surface and object A, and mu B between object A and object B. So when we get such a problem involved a pulley and connected bodies, we need to think about the physical aspect. What happens when we have this condition? So let's first note down the available data. The mass of object A is given as 10 kg, mass of object B as 5 kg, and mu A is given as 0.16, mu B is given as 0.2. These are the information that we have, and we are asked to calculate the acceleration of the objects and the tension in the cable. These are the two unknowns. So now let's consider this case. Object A is the heavier one, so I'm assuming, it may not be true or may be true, I'm assuming that object A is going to slide down because it is heavier and the coefficient of friction is less. I'm assuming that this is going to slide down. When the sliding happens, when A slides down, B will be sliding up, right? When A slides down, B will be sliding up. And what about the distance? Okay, let's consider this block A slides down by an amount x. When block A slides down by an amount x, what is acceleration basically? Acceleration is the dv by dt. What is dv by dt? Rate of change of velocity. And what is velocity? It is the rate of change of distance, right? These are the basic concepts. So when block A is sliding down by an amount x, block B will be sliding up by the same amount x, right? So what about the velocity for A? If you are considering this sliding happened in a time interval, say t, okay, in a time interval t, both A slide down by x and B moved up by x. So the velocity will be x by t. The velocity of A moving down is x by t, velocity of B moving up is also x by t. So what will happen to the acceleration? Acceleration is velocity by time. So we can find that the acceleration for object A and acceleration of object B is equal in magnitude, which means that object A will be having an acceleration in this direction and object B will be having an acceleration which will be having the magnitude same as that of A but in the opposite direction. Fine. So with this basic concept we are approaching the problem, and to solve a problem the best tool that is available with us is the free body diagram. So we are going to try the free body diagram approach. So here first I am trying with free body diagram of B. I can go with A or B, both are fine here because the motion can be predicted easily. If A is moving down, B is moving up. That's what we are assuming. So free body diagram of B. So I am drawing the block. So this is block B. It is having its weight acting downward. Mass is 5 kg. So weight will be 5 times g or 5 times 9.81, where g is the acceleration due to gravity. and we can see that this is making an angle 45 degree because of the profile of the slope given in the problem. Then what are the other forces in the system? What about the reactions? Reactions are always normal to the surfaces in contact. Here the surfaces in contact are A and B surface, which means this particular surface. So normal to that, we will be having a reaction. I'm calling it as N1. And apart from that, what we have in the system is the tension in the cable. I'm calling it as T. And as this pulley is frictionless, the tension in both cables, the cable here and the cable here, will be same because this is a frictionless pulley. So that both the tensions are T, and I'm marking the T. That is the tension. Now this object B is moving up. That's what our assumption is. When this is moving up, what happens to the frictional force? When something is moving up, the frictional force will be opposing the motion, that is mu B N1. Okay, the frictional force is mu B N1. So this is what we have for the free body diagram of block B. Now we need to assume some direction before starting. So I'm assuming this as my x direction and this as my y direction. So I have the x and y directions. Now I'm going to write the sigma fx and sigma fy. So first I'm trying to write sigma fx. Now I need to write the right hand side, whether it is 0 or it is ma. It will be 0 if it is in static equilibrium in that particular direction. It will be ma if it is in motion in that particular direction. If we consider the x direction, this particular block B is not moving in x direction, it is only moving in the y direction given in the problem. It can only move in the y direction, which means that the acceleration in the x direction is 0. So I can either use the static equilibrium condition, or I can write mbax, where ax equal to 0. So it's the same as the sigma fx equal to 0, which is our static equilibrium condition. So now we are substituting, calculating the different values. So I need to have a positive direction. So this is my positive x and this is my positive y. So I have n1 in the positive direction, then 5g sine 45 in the negative direction. So 5 into 9.81 into sine 45 in the negative direction. Okay, 5g is this, 5g cos 45 is this, 5g sine 45 is this. So 5g sine 45 equal to 0, which implies n1 is equal to 5 into 9.81 into 1 by root 2. When I calculate that, I'm going to get it as 34.68 Newton. So that's the value of n1 what I'm getting. Now I need to try the other direction, that is sigma fy. Sigma fy equal to mb times ay. And here this block B, or the object B, is having an acceleration in this direction. That's what our assumption is. So the block B is moving upward. So this is the direction. So now let's try writing it. So this value of ay, the acceleration is in the assumed positive direction. Assumed direction is positive upward, acceleration is also upward, so it is plus a. Now I'm going to write that equation. So in the y direction I have t acting upward minus mu b n1, which is acting downward, hence it is negative. Similarly 5 into 9.81 into cos 45, that is also acting downward, equal to mb times a. mb we have the value as 5, so 5a. So now we can substitute different values. T minus mu B is 0.2, 0.2 into 34.68 minus this parameter, we already got it, 5 into 9.81 into 1 by root 2, which is 34.68 is equal to 5a. So with this we have our first equation. Okay, by considering free body of B, we have our first equation. Now let's consider the free body diagram of block A. So block A is available. It is having a mass acting vertically down, which is 10 kg. So converting it into weight, I'm having 10 g. And here also this angle is 45 degree from the problem definition. Then I'm going to have reaction between the surfaces in contact. This block A is in contact with the slope, so I will be having a reaction. I'm naming it as N2, and here I already have N1. Okay, just like in the first problem, when two surfaces are in contact, if we have the forces in one, in the other one it's just opposite. Here N1 is to the right, so N1 to the left. Mu B N1 to the bottom, so here mu B N1 will be upward. Okay, and then there is a cable. Okay, there's a cable which will be having tension T. We know that as it is a frictionless pulley, the tension in the cable, both the cables will be T itself. And then there will be a frictional force. This block is moving down. Okay, block A is moving down, hence the frictional force here will be in this direction, that is mu A times N2. The normal reaction is N2, so I'll be having mu A times N2. Now I need to think about the acceleration of this block. This block is moving down, hence the acceleration is downward. Here also I am going to use the same coordinate system what we defined earlier, and I am writing the two conditions. So first one, I am writing sigma fx, which is ma times ax. We know that this block is not having any movement in this direction, the only movement is in this direction. So in this direction the acceleration is 0, which means this is 0. It becomes the equation of static equilibrium, the same one. Now I'm going to try writing it. So the different forces are, one is N2, okay, in the positive x direction, minus N1, negative x direction. Then the component of this 10g, that is minus 10 into g, that is 9.81 into sine 45 equal to 0. Okay. So from this I can write N2 is equal to, so N2 can be calculated. We have the value of N1. N1 is 34.68. If I substitute all those values, I am going to get the value of N2 as 104.04 Newton. That is the value of N2. Now I am trying to write the sigma Fy, that is ma times ay. Now what about ay? The acceleration is in this direction. The assumed positive direction of y is this. So acceleration is opposite to that. So this value will be minus a. Earlier the assumed y direction was this. The acceleration was in the same direction, hence we used plus a. Here also the assumed y direction is this and the acceleration in the opposite direction, so it is minus a. So we need to be careful about this. Now let's substitute the different values. So in the y direction what I am having is t upward, then mu b n1 upward, mu a n2 upward, then 10g cos 45 downward. It is 10 into g into 1 by root 2 downward, hence it is negative. That's the left hand side, is equal to MA. MA is given as 10 kg. So 10 into minus A. Okay. So we have different values. So we can substitute those. So it's basically T plus mu B is given as 0.2. 0.2 times N1. N1 we got it as 34.68 plus mu A. Mu A is 0.16 times N2. N2 is 104.04. Then minus 10 into 9.81 by root 2 is equal to minus 10A. And that's my equation number 2. And when I solve this equation 1 and equation 2, we can see that there are two unknowns, T and A. Here also the unknowns are T and A. So these are simultaneous equation with two unknowns. Two equations, two unknowns. It can be solved. You can use the calculator, just feed it in and you will be getting the values. And on solving, you will be getting the value as acceleration A is equal to 0.277 meter per second square, and the value of tension T is equal to 43 Newton. This is the final solution expected from this problem. The acceleration of the block A and block B is 0.277 meter per second square. The tension in the cable is 43 Newton. This acceleration, you should remember, acceleration is having magnitude same for both, but the directions are different. For block A, this 0.277 meter per second square is downward, and for block B, 0.277 meter per second square is upward. If in the very beginning of the problem, if I had assumed in the other way, that is, I assumed that block B is moving down and block A is moving up, the final answer what I will be getting will be negative. So there is no problem even if you assume the block is moving down or block is moving up. Accordingly, you will be getting the direction or the value of the acceleration. Okay, here our assumption was right. That's why we got the value as positive.